Good evening, everyone, and welcome back to White Fortress Cybersecurity. लास्ट वीडियो लेक्चर में हमने देखा था कि हम दो पीसीस को कैसे कनेक्ट कर सकते हैं, डिफरेंट काइंड के डिवाइसेस को हम कौन सी केबल से कनेक्ट करते हैं, सेम टाइप ऑफ डिवाइसेस को हम कौन सी केबल से कनेक्ट करते हैं, सभी चीजें, है ना। और मैं पहले ही बता दूं भाई, आप लोगों के कोई भी डाउट्स हो, कोई भी क्वेश्चंस हो, साथ साथ पूछते चलना। एंड मैं सभी के डाउट्स के जो है रीड करके रिप्लाई दूंगी। सो देयर इज नो प्रॉब्लम विद दैट। एंड ये हिंदी इंग्लिश का भाई तुम लोग बता दो मेरे को, विच लैंग्वेज डू यू प्रेफर द मोस्ट, बिकॉज सम प्रेफर हिंदी, सम प्रेफर इंग्लिश। So let's just keep it in English for now. Let's start. So in the last video lecture, we saw that if we have got two similar systems, like if we want to connect PC to PC, if we want to connect switch to switch, or if we want to connect your router to router, we will need a cable that has got different kind of pins. Sorry. So for that, we will use crossover cable. Okay, even in the theory part, we concluded that why we need crossover and straight through cable, and they're both used for different purposes. So simply again, let me tell you, if we talk about same kind of devices, just a second, let me check if I've still got that one. I don't think so. Okay. For again, for the same kind of devices, like your PC to PC, your a switch to switch, router to router, you want to connect same kind of devices. For that, you're gonna use which cable? Crossover cable, because it has got different pins at both the ends. Okay, and for the different kind of devices, you need straight through cable. I hope I'm very clear to you in this thing, because when you are starting with the practical, you really needed to know the theory that I've already taught in the previous lectures. Why? Because if you do not understand the basic theory, you will not be able to do the practical part really well. So let's continue. I showed you how a hub works. Okay, I showed you that simply give IP address to all the systems and connect it with the hub using the straight through cable, because these are different kind of devices. Like you're connecting PC to hub, or you're connecting PC to switch. Okay, here I connected PC to switch, or you are connecting. Hello, Hume. Welcome back to the channel. Very good afternoon, everyone. Okay, so if you're connecting different kind of devices, so you need straight through cables for that. So now what we will do simply, if I go to the simulation mode and I send the packet from one system to another system, you will see that our hub always broadcasts the packet. So it receives the packet and it will copy the packet to all other ports, right? And then again, when it receives a reply, it will again broadcast, but the system for which it is meant for will only receive the packet. Thank you. How you doing? I'm doing good. And I'm just okay for now. Okay. Let's continue. We have got a switch then. In the switch, I told you that this was your homework to configure the switch on your own. But those who haven't configured it yet, let me tell you how to do it. Again, you go to each PC, you connected it using the straight through cable. Where is the straight through cable? Here you can see you have got this orangish icon that is for your cables, and then you pick the cable from here. If I want to use copper crossover, I will pick this one. If I want to use straight through cable, I will pick this one. Okay, so it depends. on which devices you need to connect. So I already told you, just screenshot this. This is the only thing you need to remember in the start. Okay, same kind of devices use the crossover cable directly. Different kind of devices use the straight through cable directly. And I hope I'm audible to you guys. If my voice is unclear or is not very like it's low, so you can just tell me. Okay, now let's just go to one by one to each PC and we need to configure them. We need to give IP address to them. So I will go to the desktop. Okay, from here you give the IP, go to the desktop tab, then go to the IP configuration. Then here we can simply give the IP addresses like 192.168.1.1 I have given to it. I'm gonna copy it for now and do the work. Whatever work you do it in the real time mode. Here you can see the real time mode, here you can see the simulation mode. So real time mode is really how your thank you so much, Hume. My voice is good. Thank you. Yeah, I'm really speaking in like a normal person today, I think. Daily I'm in a rush, I think. Okay, so we have got simulation mode in which we can see how a packet travel. Okay, but in real time mode, it's just how the packets travel in the real time. Okay, hello Shiv Chauhan. Good afternoon, everyone, and welcome back to the channel. Thank you for the hearts. There are so many I see. Okay, let's continue then. Now I go to the another PC. Let's give the IP address to it as well. Now here I will give the 1.2. Okay, for now you can see I'm providing the IP addresses manually. Okay, I'm providing the IP address manually. Here you can see the static. We can also provide IP addresses in the real systems. We provide the IP address using the DHCP. So for now we are not using DHCP, rather static, manual. I hope you know how to give static IP to your systems as well. Hello, Onion Vulnerable. Hello, welcome back to the channel. Long time no see. Nah, ma'am, we all know you are a classified AI model. Don't worry. Do I look like a AI model to you? Onion Vulnerable, why do you delete the message? You always delete the message. Okay, let's see. Now I've given the IP address to this as well. Okay, we will later on learn how to configure the DHCP as well. How to start with the DHCP. For that, we will need router. For now, I'm showing you some very basic networks. Okay, and we're not even connecting it to the router yet, but I will show you today. Okay, again go to the desktop IP configuration, then again I'm giving an IP here, that is a 192.168.1.3. You have to give the IP address of the same network. What if I don't give the IP address to the same network? Let's see. Okay, so I go to the desktop, I go to the IP configuration. Now let's give the another network. Let's say I'm giving it, instead of 1.4, I'm giving it 2.4 for say. Okay, just to show you guys that what will happen if the packets are not in the same, if the devices are not in the same network. So let's see. So I'm sending the packet from this system to this system. Okay, let me type the IP addresses of each system for the for the confirmation. It has got 1.1, it has got 1.2, it has got 1.3, it has got 2.4 for now. Okay, so it has got the different network IP address. So that's not what we should do. So let's see what will happen. So I send the packet from this system to this system, it was successful. If I send packet from this system to this system, it will be still successful. But what if I send the packets to this PC? So let's see. It's showing in progress, and here you can see the packet will fail. Why? Because they are not in the same network. Okay, let's delete it now. So again, make sure that you know which IP falls on the which network. If you're giving the wrong IP address, it will not work. So that's why I always tell students to write the IP below the systems as well, so that you do not forget which IP is given to which system. Okay, so it is very necessary for you guys to note down the IP addresses of each system if you're working with the Cisco Packet Tracer. Otherwise, you'll have to keep on checking again and again. Okay, one more thing I want to show you guys. If you hover onto a system, okay, I hover onto this. Okay, here you can see a tab opens. You can see the device name, model, and port number, and on which port what IP is given. So you can see here that on the fast Ethernet 0 port, the IP address is 192.168.1.4, and what is the MAC address as well. So this is how you can also check the configuration of the devices. Let's move on to the repeater now. So how to connect a device to the repeater? Again, we will need the devices first of all. So how do I select multiple devices at the same time? You need to press Control Shift and then click on the PC. Okay, so that I can pick multiple PCs at the same time. So now I'm going back to the cable to connect these systems. So here I'm gonna choose the straight through cable again because they are different kind of devices. So Control Shift again. Okay, I'm pressing Control Shift again and then I click on the straight through cable. So here I am just simply connecting it. So here you can see, you saw that there was Ethernet 0 port, then there is Ethernet 1 port. We also call the repeater as two port intermediary device or something like that. It has got only two ports. Okay, the repeater has got only two ports. And what was the repeater used for? I already told you that in the theory part, that repeater is basically used to boost the signals, right? So let's continue. Here I'm putting the IP address again. So let's take some other network this time. Let's take 2.1 here and let's take 192.168.2.2 here. So here again we have got the same network for these devices, right? Here which network I am taking? 2.0, and here the network was 192.168.1.0. So I hope guys you know what are network addresses, what are IP addresses. I have discussed it all in the theory part. Now, let's give the IP addresses. Just writing down the IP addresses here doesn't mean you have provided the IP. Do not forget that. Then go to the desktop IP configuration. Now I'm gonna give the IP address, that is your 2.1. 2.1. Let's copy it. Okay. Now going to the next system, desktop, IP configuration. Let's paste the IP over here, hit enter. Now let's send the packet from this system to this system. Okay, here you can see successful. So repeater basically doesn't do much. Now extend the range. Which range are you talking about here? Oops. And guys, please do like the video. Let's continue. So here we made some basic network. So we connected PC to PC. We also can just simply go to the system. Okay, we can simply go to the system here, and I can just with the command prompt I can ping this device. Okay, let's try pinging. I hope you guys know what pinging means now. Uh, Font size. I cannot increase the font size much over here. But let me show you ping. I want to ping 192.168.168 dot. Here you can see 1.4 IP address. Okay. So here you can see it is also getting the reply from 192.168.1.4. Repeater is useful for extending. Yes. Repeater is actually very useful for extending the range, especially in the remote areas where there are hills and trees, and also even in a single building. If there are many rooms or there is a huge building, repeaters still wired repeaters can still be used in that case. Okay. Now these were some basic networks, basic stuff you needed to know. So same devices, then we talked about hub, we talked about switch, we talked about repeater. Now let's get to the main device, that is your router. So from here, from the network devices, I hope you all can see over here, or let me just use the magnifier for a while. Just a second. Hello. Hello. Stream. Stream. No issues. Bye. Okay. So, everyone, if you got any questions, any doubts till now, you can definitely ask me in the hub part, in the switch part, or anything. Okay. Now, here you can see we have got some network devices in which we have got routers, we have got switches, we have got hubs, we have got some wireless devices. So, you click on them and you can see all of it. So, going back to the router, I'm going to choose my favorite one, that is your 2911. It's just my favorite. I don't know why. I've just used it a lot. It has got three ports. Okay, I'll show you in a while. And let's just pick up some switch as well. So from here, switches, I'm gonna use this one, 2960. We have got this PT switch, which has got lesser ports. You can also use this one. Okay, and we have got a PT empty switch, which has got no ports at all. So I'll show you this PT empty to you as well. Okay, and that's it. We need to pick some PCs now. So here I've got a PC. Let's pick this PC, and I'm using Control Shift to select many devices at a time. So if I just click on it and I put it, see, it left. Okay, if I click anywhere else, I cannot just again put another PC over here, right? So for that, what I can do is simply press Control Shift and then press the PC. Here now I can put as many as PCs I want. I hope this is visible. Okay. So use Control Shift key to pick multiple devices at the same time. Okay, now let's close the magnifier. I don't think it's needed anymore. So I am then to escape this thing, just click escape so that you can again click on the devices and check the configurations in them. So I'm going to the switch. Okay, here I go to the switch, and here you can see it's PT empty. It's empty. Okay, if I zoom into it, you can see there are no ports at all. If I go to the configuration tab, you can see there are no interfaces at all. Okay, so that's not what we need, but we can also put some interfaces from here. Here you can see modules. So if you just shut this off and here you put these, so these are some interfaces, and you just switch it on, and here you will find some. Here you can see Ethernet 0/1, Ethernet 1/1, some interfaces. You can put them like this. So I do not need this PT empty switch at the moment, so let's delete it. I chose this one, PT switch PT. Okay, so I also had some other switches like 2960, which has got total of uh, router. My favorite is, yes, I have got a favorite router, that is this one in the Cisco Packet Tracer. Okay, so we have got PT switch over here. Let's see how many ports are in this one. So here you can see we have got four normal and 2 gigabit Ethernet switches. Okay, no, we have got all six ports are there. 0, 1, 2, 3, 4, 5. We have got six fast Ethernet ports over here. Okay, so that's enough for now. And if you need even more ports already present in the system, you can choose this one, 2960, which has got like 24 ports. Okay, here you can see, just boot up fast. It takes time to boot up. Okay, here you can see there are 24 fast Ethernet ports and 2 gigabit Ethernet ports connected to it. So let's delete it. And I want to delete the extra PCs as well. Let's just use four PCs at the moment. We do not need more than four PCs right now. Okay, so here I took the router. Here I have got four PCs that I'm gonna connect using the switch to the router. Okay, so now let's take the cable. So which cable do we use to connect the different kind of devices? I told you that is gonna be your straight through cable. So I am pressing Control Shift and then I am pressing onto this crossover cable. Okay, now click on it. Select, it has got gigabit Ethernet port, gigabit Ethernet 0/1, 0/2. So you need to click like choose one of these three ports. So I'm gonna choose this one, then I'm gonna connect it to the fast Ethernet port of the switch. And I'm still holding, here you can see it has got the cable, which is a straight through cable. I'm still holding the straight through cable because I use control shift. So now select the fast Ethernet one and connect it to the devices one by one. Okay, here I am connecting fast Ethernet 3 to this one. Here it has fast Ethernet. Okay, here you can see cable cannot be connected to that port, because if I show you one thing, that if I show you the physical interface over here, okay, I'm gonna zoom in. Here you can see these two ports are some different kind of ports which cannot be used to connect to the PC. Okay, so you cannot use these two ports. So I can simply either remove these ports and just use some other ports. Okay, so I'm gonna just switch it off, and I can just simply to remove these, take the port, drag it here. It's gone. Okay, and I can switch to some better ports which I can use. Now I switch it on again, then go to the configuration. Here you can see fast Ethernet 4/1, 5/1. You can simply use these ports to connect. Okay, so now it's on. And here, one more thing, you can see these orange dots. What does these orange dots mean? Means the MAC table. I am back. I am back. मैं अपना वाईफाई हैक कर रहा था. Damn, Shiv Chauhan, that's great. You were hacking your Wi-Fi. I hope you guys are learning a lot from the channel. That's all we need. Okay, now you see that orange dot is gone to the green one. I'll show you why that happens. Let me tell you. Okay, so first let's connect this last PC using the straight through cable again. I'm gonna pick the 4/1 over here and connect it over here. So it's also done, but here you see orange again. So that is because our table is being updated. Okay, I hope you guys remember what is ARP table, MAC table. So switches got the MAC table thing. They send the ARP packets, ask for the MAC address so that they can send the packets really well. So let's forward the time. Here you can see the fast forward and it will turn green really quick. So whenever you see these orange ports, that means your packets cannot travel from one system to another system. What you need to do is simply fast forward the time in the Cisco Packet Tracer. But in the real life, that really doesn't happen. So you need to wait for the system to really boot up for real. Okay, so now you can see I've connected multiple systems and ultimately to the switch, and switch is then connected to the router. So we'll configure each of these, and we can also configure DHCP if you want me to. So first, let's give it manually. Okay, let's give first of all everything manually. Then we will do the DHCP thing. So what I'm gonna do is I am gonna go to every system. Okay, let's go to every system and give the IP address. Okay, so let's first decide the network that I'm going to give to them. So network I'm gonna put them on is 192.168.1.0. I hope this is all visible to you. So I'm going to put this to this network. 192.168.1.0 is the network that I'm going to give to the system. Okay. So for the each one, I'll have to give for each interface, I'll have to give the IP address. So here router has got one interface and I'm going to give the router the first IP address because it's going to be the default gateway. What is default gateway? I hope you remember the gateway which or the device, an intermediary device on which our systems rely on to send the packets to the different network or ultimately to the internet. So here I'm going to give it 1.1, and the other systems I will give the 192.168.1.2 for same. Here I'm going to give 192.168.1.3. Here I'm going to give 192.168 dot 1.4, and here 192.168.1.5. Guys, and one more thing, just while you're configuring these, just select this switch. Okay, it's gonna be easier for you. Select this 2960 switch. मम्मी बुला रही है, जाना पड़ेगा. नो इश्यूज. आप रिकॉर्डेड लेक्चर भी देख सकते हो, एंड वी ऑल्सो आप जा सकते हो. ठीक है, एंड वी हैव आल्सो गॉट like our courses of CCNA. You can contact on the number that is given in the description if you want to learn from us. So here I've given the IP address to this port. Now let's configure them one by one. So, and if these ports are not visible to you guys, okay, fast Ethernet 0, fast Ethernet 0/1, what will you do? You will simply go to the options over here, then go to the preferences, and in the preferences, always show port labels in the logical workspace. Tick on this. Okay, if you really want to see all the ports that are given over here. Okay, now let's give the IP address. Uh, we are going to go to the configuration terminal for now. Okay, because then we will move to the CLI. In the next video lectures, we will work on the CLI. Okay, going to the configuration part, then go to the gigabit Ethernet 0/0. Okay, here I am gonna give it this IP. Okay, already I have written it. Go to this 192.168.1.1. Okay, now here you can see on. Okay, port status is off for now. You need to turn it on. So here you will see the red will become green. That means now it is on, and it will take a little bit time to update the MAC table again. It's gonna send some R packets and everything in the meanwhile. Okay, let's open this. Go to the desktop, IP configuration. Again, give the IP addresses. Okay, that's all you need to do, guys. So let me give the IP address to these systems real quick. Okay, there is one thing that we are missing. Okay, that is we haven't given the default gateway yet. So do not forget to give the default gateway as well. So let's give the default gateway. What is going to be the default gateway? The IP of your router, of this interface, which is connected to your network, okay, which is connected to these PCs directly. This is gonna be the default gateway for your system. Even if I show you the default gateway of my system, let me show it to you. IP config. Here you can see, sorry, I forgot. Open the CMD, then IP config. Here you can see what is the IP address. Here you can see the IP address, and what is the default gateway. It is the first IP address of my network. That was 192.168.0.1. So here it's gonna be 1.1 because we are at 1.0 network. Okay, so do not forget to give this default gateway IP address. And here you can see if I give the IP address that is already allotted to other system, it will say this address is already used in the network, means give some other IP address. Okay, so let's shut it. And even the first switch, let's click on it, go to the IP configuration, and do not forget to give the default gateway of it. Now going to this system, third system, go to the desktop again, IP configuration. Okay, so I hope now this is clear to you guys how to give IP addresses to the system statically in the Cisco Packet Tracer, and even the default gateway. This is how you give it. And if you got any doubts, any questions, you can ask me. Okay, now let's send the packets again. I can send the packet from one system to another system easily, right? Here you can see the packets are successful. Last status successful. No matter which packet I send to where, it will simply be successful. Then, if I want to send the packets to the router, what will happen? Let's see. It will be still successful. Okay, I can send the packets to the router as well. Okay, That means this small network, including the router, is working really well because they have got the IP addresses of the same network address. This is the network address 192.168.1.0, and other IP addresses all fall into the same network. Okay, I hope this is clear how to connect it to your router. Now, if I want to connect one more network, okay, let's connect one more network to this router. Let's see how I can do that. Let's just take, it's already connected to this one now. Let's just take one more switch. Here I'm taking this switch, 2960 switch. Let's open it. Here you can see it has got so many ports. Okay. There are 24 fast Ethernet ports and there are 2 gigabit Ethernet ports if they are visible to you guys. Okay, these at the corners are the gigabit Ethernet ports. Also in the configuration, you can see the name of all these ports over here. So let's close it. And one more thing, there are many students that do this silly mistake that we are not giving any IP address to this switch. Okay, we haven't provided any IP address to the switch because it is not needed yet. Okay, there is no need to provide the IP address to the switch. Only to the routers, this port, and the fast Ethernet ports of all these switches. All these PCs, sorry, not switches. Okay, now I'm gonna connect one more network. So this network was 192.168.1.0. Let's connect another network, 192.168.2.0 to this. Okay, this is gonna be another network. And so I'm gonna take the cable. First, let's take the devices. Okay, I'm gonna choose the PC. Here I've taken two PCs over here. Okay, you can also name them like this, PCA, PCB. You can also name your PCs like this, admin or Yash or John or anything like that. You can just put the name over here. Okay, now let's take the cable. Which cable I'm gonna select? Guys, tell me which cable to choose to connect the different kind of devices. Sorry. We are gonna take the straight through cable. Control Shift and then select the cable. Then one by one, I'm it's the second port is gigabit Ethernet 0/1. It's asking which port. You can simply select the fast Ethernet 0/1 or whatsoever port is of your liking. Okay, it has got 24 ports in total. But which port are you gonna connect it to? Fast Ethernet port of the uh, fast Ethernet port of the switch, and also the fast Ethernet port of your this PC. Okay, so you should know which port to connect where. Now let's give the IP address over here to the router. I'm giving the IP address 192.168.2.1. Okay, because now it's gonna be another network, right? So of this interface 0/1. Previously, this interface was 0/1. So I gave IP address to this one. Okay, here I'm gonna show you. Go to the configuration. Here 0/0. I've given the IP address to this port. There are many other ports 0/1, 0/2. I'm not giving IP address to any of those. Okay, so I've given IP address to this one. Now, let's let's give the IP address to this one first. I'm going to the router. Here I've got the port number over here, gigabit Ethernet 0/1. Go to this. Then type the IP address 192.168.1.2.1. Sorry. Okay, hit enter. And here, do not forget to turn this on. Okay, port status on. Click on on. Until or unless you hit the on thing, it won't work. Okay, here you can see now the signals are green. Previously it was red. Okay, let's go to the PC as well one by one and let's type the IP address I want to give to them. Note, hit the note 192.168.2.2 for this system and 192.168.2.3 for this system. Okay, hit escape. Now go to the PC, go to the desktop, go to the IP configuration, then again give the IP address to the system. That's gonna be a 192.168.2.2, and here it's gonna be 192.168.2.3. Desktop IP configuration. Okay, and here I'm gonna give it 192.168.2. Dot, 2 dot, I'm so sorry. 192.168.2 dot 2 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 dot 192.168.2.3. Okay, hit enter. So I forgot to give the default gateway. Do not forget to give the default gateway. Now, what is going to be the default gateway? So for these systems, it was connected directly to the router's gigabit Ethernet 0/0 port, which has the IP address 192.168.1.1. So for all these three PCs, this IP was gonna be the default gateway for them, 192.168.1.1. I also told you that in a gateway for your system will be on which it should be on the same network as the PC. So for these PCs, it is on the same network. Now, for these two PCs, what is going to be the default gateway for them? Here you can see 192.168.2.1, which is on the same network as these PCs. Hello, Sahil Kumar. Welcome back to the channel. Okay, so for these pieces, I'm going to give which default gateway? This one, 192.168.2.1. So here we are discussing the default gateways, everyone. So here, let's give I've already given the IP address. Let's give the default gateway, which is going to be 192.168.2.1. I hope this thing is clear to you guys. Now let's go to this PC. And here also, let's give the default gateway 192.168.2.2. Okay, hit enter. That's it. Okay, that's it, guys. Now let's send the packets from this system to this system. Let me delete the previous packets that I already have here. So let's forward them. Sorry, send the packet from A system to B system. You can see this is successful. And if I want to send the packet from A system to the router, let's see if that's gonna be successful too. Here you can see it is also successful. If I want to send the packet from B to router, it's also gonna be successful. Okay, so here you can see this is how we can connect two different networks to the router. Okay, but what if I want to send the packets from this network to this network? They are totally different networks. So it has got 2.0 network, it has got 1.0 network. What will happen if I want to send the packet from this system to this system, which are totally completely in the different networks? It's showing successful. Let's try some other device. It should not show successful. Okay, it should not show successful. It will show failed every time. Okay, I will tell you why that one was successful. Okay, so here you can see every time this will show failed. Okay, every time, no matter which packet I send, which system I send the packet to, it should show failed. Okay, but if I'm sending it to this one, it was showing successful. Okay, let me show you in the simulation mode as well what happens to the packets. So I'm sending the packet from device A to this PC13, and I'm going to forward the packet. So it goes to the switch first, then to the router, and nowhere else. So basically, this device did not send the packet to this system. Okay, it did not send the packet to this system at all. So the you also I also showed you that the packet will fail. What happens if I'm sending to this system? It's going, right? Even though they are in the different network, it's still going. Okay, here it moved to here, then it's going to there. It's somehow, I don't know why it is showing successful, but you can see over here it should not be successful at all. Okay, here you can see it's failed now. So what I mean to say is, if you want to send the packets, if let me type it in the notepad, you can not send the packets in the different networks without routing. Okay, there is a feature in the router You haven't come live for few days. I've been facing a lot of personal issues. Hey Sahil Kumar, if you have got any doubts, you can definitely ask me on the WhatsApp, and the number is given in the description. Okay, wait. I think you have already contacted me, Sahil. I think you are that one, that 17-year-old who wants to do the quantum computing or something like that. Or maybe it was Shiv Chauhan. No, not Shiv Chauhan. ओके। क्यों साहिल घर में पानी नहीं आ रहा था क्या? वाह! No, he had some questions related to his career, Shiv Chauhan. Sahil Kumar was asking some questions about his career. Okay, so what was happening here? It will not send the packet from one network to another network without routing. Now, what is routing? Okay, if you want to send the packets in the same network, surely it will send. But if you want to send the packets into the different network, it will not send at all. Okay, that was just a misunderstanding. That is because here you can see I added some. Wait a second. Where is the that? Wait, here. Okay, what happened actually was that here it had Ethernet 4/1. Because of that, it was showing some problem. But if you will pick this router, na, it will not show any kind of problem. 2960. So it will like not send the packet in the different network without the routing. Now, what is routing? Let's discuss that first. Okay. I have got it's little bit of theory, then it has got all the practical. Okay, you need to understand a little bit of theory. No bro, you don't have to study, but I have to attend networking class every day. Oh, Sahil Kumar, oh, I forgot. You were doing like CCNA or something in that. Oh, my bad. Are they working on Cisco Packet Tracer? I've already completed the theory part, Sahil. I remember now what problem you were facing. Actually, guys, I was busy with the offline opening of our White Fortress Cybersecurity. We are now offline as well near Shadra. Those who want to like study offline from us or want offline courses from us, you can simply contact on the number in the description, and I will share the address with you. And you can visit us, take the demo class, and everything. Let's continue. We have got routing now. So, routing is a process in networking that involves directing the data from its source to its destination. So, what happens? Router or any intermediary, any other intermediary device, like it could be a firewall, it could be a router. What they have to do is help devices communicate with each other, help devices pass the data from one end of the network to another end of the network. So, does the router do. So, routing, it just involves directing the data from its source to its destination. In a network, data is often divided into smaller units called packets. We already know data travels in small units that are your packets, and routers are devices that play a crucial role in determining the path these packets should take to reach their intended destination. So, routers are the devices which are very, very crucial in a network. Okay, there could be firewalls also in the case instead of routers, but that's a later on topic. Okay, so first routers we are talking about. So, they are very crucial to determine the path. They select the best path for each and every data packet that is traveling from one system to another system. Okay, or one network to another network. So routers decide which path is the best for them. So let's see how. So for example, I have got many routers. Let's take a few routers. Okay, I'm just gonna teach you a little bit of stuff. Okay, here I've got multiple routers. Okay, I have taken four routers and let's connect them. So for say these are routers, there are many systems that are connected to routers. Okay, just for example, I'm just putting this network like this. Okay, so escape. So for say I have got multiple routers and I have got multiple devices that are connected to these routers. Okay, so if this system wants to send the data to this system, the packet will go to the router. Now router can send the data from here, then here, then here, or it can also take another route from here to here to here. Okay, let's add one more. Okay. To delete the cable, how do you delete the cables? Let me tell you. Press the del key. Okay. First, the make sure you haven't selected anything. No device should be selected. So press the del key. Here you will see cross like this. Hit on it. Okay. Like this, you can delete the cable. So I'm gonna take one more router. Router. Let's connect these again. Okay, so for say there are here you can see it has got this route from this system to this system. It has got path one. It has got path two. Okay, there are two paths that are there to send the packet from this system to this system. So, what happens in the routing table? There are a few types of routing tables. First is neighbor table. In neighbor table, what does router store? Like, for example, there is a router over here, you can see. Okay, so it stores the data in the neighboring table. If look, different devices make the different kind of routing tables. Okay, we will get to that part later. So what happens? This router is making a neighboring table. What will happen in the neighboring table? It will just have the address of its neighbor. Okay, so which IP it is sitting on, which IP this router is sitting on. It will only have the address of their these neighbors. Okay, so it will simply send the data to the neighbors. Next is the topology table. So we already know what is topology. Guys, you have any questions and doubts, so you can ask me in the chat. After seeing your message, I did a bit of research and decided that I will study quantum computing along with cryptography. I won't add anything extra now. I'll just focus on this because trying to add too many things might stop me from learning anything properly. Yes, Sahil Kumar, I think you should just start already. Okay, what is topology table? Now, in topology table, the router will have information of complete topology. Okay, so whatsoever devices are connected to it will be in will be the topology. Okay, I have got another example picture for you as well, guys. So for say this is a router 5. So what it will store in the neighboring table? Only the address of router 4 and router 6. And if we are talking about the topology table, it will store the path. Like it will know that router 4 is here, router 6 is on the right, then to the router 6, router 7, router 8, router 9 is connected, and on the left there is router 4, to which router 1, router 2, and router 3 are connected. This is your what do we call your topology table. Okay, so in neighboring table, directly connected devices. In the topology table, linked devices. Okay, well, like I just showed you, router 4 is connected to other routers also on its left. So topology table will have the list of all those devices and the address of them. Next, in the routing table, all possible routes. Like for example, let's go back to this one, this image. Okay, so what will happen? Uh, there is one called feasible table. There is one called successor table. Just a second. This is, I should have kept those images closer. Routing table, successor table, and feasible table. Okay. So what will be stored in the routing table? In routing table, it will have all the paths. So for example, packet is coming from here. Okay, for example, packet is coming from this. So route when one from this from here, it wants to go here. So there are multiple paths present. It can send from here, then here, then here, then here, then ultimately here, or it might just move it a little more from here, then here, right? So there are other paths as well. It can directly send from router 1 to router 4, 5, 6, 7, and then ultimately to this network. Or it can just send it to router 1, router 2, router 4, router 5, router 6, then router 8, then router 7, and ultimately over here. So there are multiple paths that are present. So what will be in the routing table? It will have the all the possible paths. But successor table will have the best path. So how it will know what is the best path? It could be this path, it could be this path, it could be any path, right? For that we have got some metrics. What are those metrics? We will discuss them later, but let's talk about one metric, that is your hop count. Okay, so for hop count means how many devices are present in between. Okay, so the lesser the devices are present, the less it will have to like hop around. So like from here, if we start, the packet come to here, hop 1, hop 2, hop 3, hop 4, hop 5, and ultimately reaching to this. So this could be the best path if we are using the hop count metric. Metric is just something that defines what could be your best path, what could be the best path for a single packet. Okay, so it could be some other. Okay, so if for example, the path, the speed of path, this one, the path, the longest path might have the fastest speed, so it will take that path as the best path as well. Okay, so I hope you're getting it, guys. If you are not getting it, you can tell me in the chat or in the comments. Okay, if you got any questions, any doubts, I will be really happy to hear from you guys. And you can also contact me in on the number that is given in the description. So this is how you guys just like it has got the best path. So for example, this was the best path, going from router 1 to router 4 to router 5 to router 6 and to the router 7, because it is the shortest path as well. But what if this path is not working? So for example, this link is broken, router 6 and router 7 link is broken. So what will happen? It will also have some feasible path. What is feasible path? That is your backup path. If one path is not working properly, it will have some other way to send the packet. So it will quickly update the routing table, and it will just send the packet from router 1 to router 4 to router 5 to router 6, then to the router 8, then to the router 7, and then ultimately here. If the best path, which was your this one, okay, router 1 and directly to the router 7, is not working well, it can what it can do, it can select some other best path, right? It can have some backup path. So moving to this again, what we got to know that routing tables, there are five kind of uh, generally there are five kind of routing tables that a router makes: neighboring table, topology table, routing table, successor table, and feasible successor. So routing table will get the directly connected devices to it. Topology table will have all the link devices. Routing table will get the all the possible routes to send a packet from one end to another end. And successor table will be best path, or the path with the best metric. And feasible successor table will contain the backup routes. So this is what we have. Now, talking about the routing metrics. So, there are some routing metrics which help in deciding the best path for each packet. So, there could be hop count. What does hop count mean? A hop count is an intermediate connection linking two or more devices. So, for example, I am opening the command prompt, and on the command prompt, I am gonna just um tracert. There is a command I told you about, guys. That is your tracert. Tracert is used for trace route. I want to tracert google.com or whitefortress.in. It could be anything. Okay, so this is the ultimately where it need to reach. Okay, google.com's IP address, the server on which the google.com is hosted. So first of all, the first hop is the router, my router. Okay, it goes to the default gateway first of all, 192.168.0.1. Then where it goes to, it will go to my internet service provider's first router, then it is my internet service provider's another router. It is routing the packet. Okay, it's this traceset commands is bringing me all the devices that are in between. If I press google.com, so where the packet will travel through, it will go to the default gateway, it will go to my ISP system, then another ISP router, then another ISP router, then it will ultimately route the packet to this IP 192.168.2.16. Oh, 217.166.14. That is your ultimately google.com where the google.com is hosted, right? So this is these are hops. How many hops it took to reach the google.com? 8 hops. Okay, it went to the router, then to another, then another. There are total 8 hops. Means 8 devices are in between to ultimately reach the packet from one end to another end. So this is your hop count. Then another metric is your path reliability. Okay, what does path reliability means? Means if I am pinging google.com, okay, if I ping google.com or whitefortress.in or anything I want to ping, so here you can see sent packets 4, received packets 4, and there is 0% packet loss. So if there is a packet loss, means less reliable network will be. The lesser the packet loss, the more reliable packet will be. Okay, so path reliability means the more the packet loss, the lesser the reliability, and the less the packet loss, the more the reliability. Okay, next is your path speed. So, for example, this PC wants to send packet to this PC. Okay, it has got, so this is the smaller path, right? One hop, two hop, three hop, only 3 hops it's gonna take. So it is the smaller path, right? So, but if I tell you the packet that are sent are going from the longer route, why is it selecting? Why the routers are selecting the longer route? They are selecting the longer route because it might be because of the path reliability, it might be because of some other metrics. So if we talk about the path speed, that means this might have some speed of 100 mbps, for example, and this has the speed of 10 mbps. MB PS. Okay, so okay, then it has got the 100 Mbps speed. Okay, this complete path's average speed is 100 Mbps, and this path average speed is 10 Mbps, for example. So, which path it's gonna take? If the router is sorry, if the router is working on this metric, path speed metric, it will send the packet to the this path, to the faster path. Okay, so this is the another metric. Next is your load balancing. So for example, let's remove these. So for example, these both are working at the 10 mbps speed. Okay, these are both working at the 10 mbps speed, so it will just check the hop count. Okay, it is the smaller one, so it should be sending the packets from this system, then this system, then this system. It should work like that, right? And guys, please do like the video. Okay, do not forget to like the video. So now what should happen? The packet should travel from here to here to here. But because of sending too many packets from this path, the speed might slow down, right? If all the packets are going on this path, what will happen? The speed may slow down. So what should happen? uh, Load balancing should happen. So it will start sending half of the packets from this route and half of the packets from this route, so that uh, there is like load can be balanced, right? Like sending all the packets from one route can slow down the speed of a single route. So to increase the speed, the packets might be divided into the two paths to send it faster. Okay, this was your load balancing, distributing network traffic equally across the network routes. Next is your bandwidth. Bandwidth is like your path speed only, like Bandwidth is a broad term defined as bit rate. Bit rate measures the capacity over a network communication system. Means it might have a bit rate of 100 Mbps. Wait, this path might have the bit rate of 100 Mbps. This path might have the bit rate of 10 Mbps. So like this, that is just like the more the bit rate, the faster will be the speed of the connection. So there is last thing, that is your latency. Okay, this is the last metric we are going to talk about, the delay in time it takes to move the data in between a node's RAM and its processor. So, to make the packets reach from this system to this system, there will be multiple devices in between. Okay, these routers, I'm taking the same routers here, but there might be some different kind of routers in the real network. So, for example, this router is taking 6 seconds. 6 second, let's say 1 second. Okay, 1 second to process the packet. This is wait. This is taking 1 second to process. This is also taking 1 second to process a data packet, and this is also taking 1 second to process the data packet. But this is taking 5 seconds to process the data packet. It is going to use for example, it is a outdated router, for example. Okay, these are the faster routes. So latency means how much RAM or how much processing power and how much time a device will take. Okay, so for example, these are taking less time and less processing power to process a packet. But this one is taking more processing time and more processing power to process the packet. So all these have got better latency than this route, right? So this is your latency. This is another metric that uh, that helps in router to decide which will be the best path. So, latency is the delay in time it takes to move data between a node's RAM and its processor. Means how much time a device is taking to process the packet. Okay. So, in routing, we have got two types of routing. There is static routing and dynamic routing. We are going to do the practical of it first. Let's do the practical of static routing first of all. Okay. Let's start. So, let's take two routers now. Okay, I'm gonna go to the network devices. I'm gonna take two routers. Here, I'm gonna put one router over here, one router over here. Let's take two switches as well. I'm gonna put one switch over here, one switch over here. And let's take a few PCs to connect. Okay, I'm gonna take four PCs over here for say. And let's connect them. So for different kind of devices, which cable should be used? For different kind of devices, I'm gonna use the straight through cable, right? So here I'm selecting the gigabit Ethernet port. Here I'm going to select the fast Ethernet port. Okay. Here I'm gonna, this is how it works in the real network, guys. Okay. It's all how it works in the real network. You need to know the cables. You need to know the router. You need to know which port is where, each and everything. Okay. So let's connect. I'm just fast Ethernet port. You should know which port you are connecting it to. Okay. Here also fast Ethernet port. Okay, I pressed Control Shift to pick the cable so that I do not have to pick the cable again and again. If you're not pressing Control and Shift while picking the cables, what will happen? You'll have to pick the cable again and again. Now, I want to connect the same kind of devices. For that, I need to use the copper crossover cable, this dotted cable. Okay, so gigabit Ethernet port over here, Ethernet port over here. So, let's just make sure that you can see the ports that are present over here. Okay, where is it? Let me adjust. Where are they? Wait a second. Let me. Huh. Okay, these are system. Let's name these PCs. So PCA. This is okay. PCA is already given to some other system. Let's take PCC, PCD, PC E and F. Okay, here I've taken some names to them. It's up to you if you want to give them name or not. It is not that necessary. Okay, I'm just doing it for you to better understand it. So now I'm going to put the network address that I'm going to give to them. Here I'm going to give the network address 192.168.1.0. Here I'm going to give the network address 192.168.2.0. Okay, I'm going to put them on the different networks. And here I have to give another network to connect these two routers as well. Okay, so I'm going to use the class A IP address over here. So let's take this network 10.0.0.0 network over here. Okay, so these are the networks I'm going to take. Now let's start giving the IP addresses to each port. So for this device, it has got two ports. Okay, here you can see gigabit Ethernet 0/1. Here you can see the port gigabit Ethernet 0/1. Let's give the IP address. And guys, if you have any questions, any doubts, do not forget to ask me in the chat. And you can also ask them in the comments later words. And if you want to learn CCNA from me, if you need mentorship for that and you have got an exam, you can contact me on the number that is given in the description below. Okay, so I'm going to give this IP address of this network. Okay, 192.168.1.1. Okay, here to this PC, I'm going to give the IP address 192.168.1.2. Here I'm going to give this PC IP address of 192.168.1.3 per se. Okay, so these are the IP address I'm going to give to these systems. And here make sure to write these IP addresses directly in front of the port that you want to assign IP address to. Okay. Do not ever um put, like, if I'm putting this over here, okay, I put this IP address over here. What will happen? You will not remember which port to give the IP address to, right? So it is very necessary for you to put the IP addresses beside the port. Now here I'm gonna give the IP address over here 192.168.2.1. Here I'm going to give the IP address 192.168.2.2. Here I'm going to give the IP address 192.168.2.3. Okay. So here I've given the IP address of this network 192.168.1.0, 1.1, 1.2, 1.3. Here I've given the IP address of this network 192.168.2.0. Okay, 2.2, 2.3, 2.1 here. And what are we doing over here? Let me write the name of the topic, static routing. That's what we're gonna do. Okay, let's continue. Um, Here it has got two more ports left, so we need to give the IP address of this. We need to give the IP address of this network. So I can give the IP address over here like 10.0.0.1, or I can give 10.10.10.1, anything. Okay, but it should be of the same network. I can also give the class B IP address. I can also give, you just need to pick some other network. Okay, not these networks. I am giving the IP address of class A because usually router is connected ultimately to the internet service provider. As you can see over here as well. है ना? Here it is connected to 38.24254.162.1, then 41, then 36. Sorry, these three. 18, 1, 41. These three are the routers that are of your internet service provider. So they are probably on the class A IP address. And here I'm putting them above the ports they are assigned to. So here you can see 10.0.0.1 gigabit Ethernet 0/1, and here it has got gigabit Ethernet 0/1, 10.0.0.2. This is the IP address. Okay, I hope I'm making it clear to you guys which IP should be assigned to which port. Okay, so let's start giving the. So first of all, what do you have to do? Do not forget these 6 steps. First, the 5, 6 steps. First is your making the infrastructure, means adding the devices. Infrastructure. Okay, that means you need to add the devices. You have to put the router, switches, and your PCs in the place. Then, second step is to write the notes. Okay, secondly, you will write down the notes. To write the notes, what do you press? Here you see. Okay, here you have got N. Here, if I hover on it, place note N. Here I press N and I can write whatever I want. And then if I want to leave this note, I can just simply put escape button. Okay, here I left the note thing. Okay, then third, you assign the IP addresses. Assign IP address to the PCs and your devices, to your this device, to your router. And again, let me tell you, no need to provide the IP address to your switch. There is no need. Okay. And later on, like in the tomorrow's class, we will also learn the DHCP and other thing. Okay. We will learn how to configure the DHCP thing as well. So assign IP addresses to the PC. Okay, that is the another thing you need to do. And then fourth, you need to do the routing and then simply send the packets. That's it. Okay, let's start giving the IP addresses. So I'm going first to the router. Click on the router, go into the configuration, and in the configuration, you can see over here gigabit Ethernet 0/0 port. Okay, go to it. Now, here I have to give this IP. Okay, 192.168.1.1. And do not forget to put this on. Okay, do not forget to put this on. And guys, here you can see some commands written over here. Okay, these are the commands that we are going to type in the CLI. Right now we are working on the graphical user interface, which is usually not the case. Okay, we mostly work on the CLI. So just to explain you everything, I need to first show it on to the graphical user interface, then we will start working with the CLI. Okay, so G0/0. Here I needed to give this IP 192.168.1.1. Then we have got another one over here, gigabit Ethernet 0/1. Right now I go to this gigabit Ethernet 0/1. Here give the IP address this one 10.0.0.1. Okay, here I'm gonna give this IP address 10.0.0.1. Okay, on, close it. Now going to the another router. Here it has got another 2 ports. It has got gigabit Ethernet 0/0. It has got gigabit Ethernet 0/1. Now I'm going to go to the configuration terminal of the router again. Then go to the gigabit Ethernet 0/0. Here I have to give this IP 192.168.2.1. And guys, if you need mentorship, if you need me to teach you everything, okay, step by step, and you need mentorship for that, you can contact me on the number that is given in the description. Okay, then I go to this interface, gigabit Ethernet 0/1. Here I'm going and I have to give IP this one, 10.0.0.2. 10.0.0.2 and hit enter. Okay. Uh, and it I'm into the simulation mode. Make sure you're working on the real time mode. Okay. And guys, if you got any questions, any doubts, you can directly ask me. Let's go. Okay. Now we have configured the routers for now. Okay. We have still not performed the routing. We are just assigning IP addresses for at the moment. Now go to the PC. Now in the PC, go to the desktop. In the desktop, go to the IP configuration. And in the IP configuration, I need to give this IP address 192.168.1.2. You can give any IP, but it should be in the same network. Okay. Now what will be the default gateway? Default gateway will be this one 192.168.1.1. This is your router's private IP address, and this is your router's public IP address, which is connecting you to the other networks. And this is the IP that is connecting your router to your PC directly. Okay, so this is the private IP. I need to give over here 192.168.1.1. Okay, you cannot give some other network's IP. Okay, that will be a blunder. You cannot do that. Now, it's all done. Now close it. Go to the another PC, repeat the same thing, giving the IP address. Okay, going to the IP configuration. Here I am giving 192.168.1.3, and here I'm going to give the default gateway as 192.168.1.1. Guys, if you got any questions, you can ask me in the chat. Okay, now moving on to the another PC over here. For this PC, I'm going to give it different IP address, that is your 192.168.2.2. Okay, and what will be the default gateway here? 192.168.2.1. 192.168.2.1. Okay, and here 2.3. Let's open it, go to the desktop, go to the IP configuration, and here I'm going to put the IP 192.168.2.3. And there is one more tip for you guys I want to give you, that please do use your numpad. Okay, whenever you're providing the IP address to any PC, any system, or you are like, do it using your numpad, not the keys that are above the in the keyboard. There are keys that are just above the letters. Do not use those. Instead, use your numpad. That will be very like time saving for you. Okay, or you can also just copy paste the IP addresses, no issues. But in the CLI, when we work with the CLI, numpad is really gonna help you out, guys. Okay, so here I'm gonna give the default gateway as 2.1 again, because that is the router's private IP address, and 2.3 as the IP address to this PC. Let's close it too. And let me check if I've already given IP address to 0/0 port over here as 192.168.2.1, and 0/1 port as 10.0.0.2. And guys, please do try to experiment on your own as well. Whatever I'm teaching you, I want you to do it practical on your own. Okay, just keep watching the video and side by side do the practical thing. I really need that from you guys. Okay, whatever I'm teaching in today's class, you need to practice it afterwards. Otherwise, you will not be able to remember anything. And the next class will be on the Monday, because on the Saturday, Sunday, I've got some weekend batches. So I usually take the class from Monday to Friday. And now I will be regular from 3 to 5. Okay, I wasn't regularly taking the classes because of opening of our White Fortress Cybersecurity offline opening. Okay, so that's why I wasn't able to take the classes. But now we are open, and okay, so we have done the assigning IP addresses and everything. Not just the IP address, also the default gateways. That is also very important. Okay, now we need to do the routing, so that, okay, so let me show you. Till now, we can send the packets in the same network. Okay, here you can see successful. If I'm sending a packet over here, you can see it's again successful. But if I want to send the packets from this device to this device, it will be failed every time. So go to the router. Here you can see routing. Okay, in the routing, you will find static routing and RIP. So first of all, we are gonna start with the static routing. Now it will ask you to give the network address. Which network address do we have to provide? The one we need to connect it to. So this is the network address. What is it? 192.168.2.0. And what is the subnet mask of this? What is the subnet mask of this network? It is 192.168. Um, sorry, I'm so sorry. It's 255.255.255.0. Okay, it is a IP, Class C IP network. So it will have the network subnet mask as 255.255.255.0. I've already taught all that. Okay, just for a quick revision, let me tell you. We have got classes. Wait, I had this one over here. Here, you need to learn these three. Okay, just you can also learn the CIDR notation if needed, but these are the main things. Okay, what are the classes? Class A, class B, and class C are there. Then you have got range of classes 0 to 127. First octet ranges 0 to 127. It will be your class A. 128 to 191, it will be your class B. 192 to 223, it will be your class C. And these are the subnet masks. So the network address I've just given was 192.168 dot your 1.0. I think, let me check it again. Yeah, it's 192.168.2.0. Okay, so this is the network address I've given. So you need to give the subnet mask as 255.255.255.0. For class B, you need to give 255.255.0.0, and for the class A, 255.0.0.0. Okay, I hope I'm making it very clear to you guys. And then there is one thing called next hop. So to explain you the next hop, I've got an image. So some people just do not understand what next hop is. So let me show you what next hop is first of all. Then we will get back to the CCNA part. Okay, so I'm gonna just open some image for you guys to make you better understand it. CCNA, static PNG here. Okay, so for example, I hope this is visible to you guys. So for example, these are our routers. Okay, these are our routers, and first router, this router is connected to 192.168.1.0 network. Okay, this is its private network. Then there is second network which is connected to 192.2.0. Then there is third network 192.168.3.0. And ultimately there is a last network that is connected to 192.168.4.0. Okay. So, and there are some ports which has, it's this port has got a, it as the IP address, it has got B IP address, it has got C IP address over here, it has got D IP address over here, it has got E port, it has got F port, and they have got some IP addresses and port. Okay, so I have a question for you guys first of all. Okay, for those, what is the difference between port and the interfaces? Okay, that's what you need to tell me in the chat box right now. What is the difference between ports and interfaces? Okay. Let's start with the routing table. Okay. So router 1. So for example, router 1 wants to connect to this one. Okay, needs to connect to network 2. Okay, router 1 wants to connect to router 2. Okay, first let's see how many networks it can connect to. So router 1 has got its own network 192. Oh shit. Just a second. Okay. So this router can connect itself to 2.0, to 3.0, to 4.0. Okay, I hope this is visible to you guys. 4.0. So which network it can connect to? Network 1. There are network 1, 2, 3. Let's put them. Each router can connect itself to multiple networks. For say network 1. Then we're gonna take the next hop over here. Okay, then net 2, then net 3. There are three networks it can connect with, right? So for the each network, what will be the next hop? That's what we are gonna learn over here. Okay, control C. Then we have got router 2. Then we have got router 3. Then we have got router 4. Don't worry, I'll make sure that you understand each and everything. Okay. Now what are we doing over here? We are making routing table for static routing. Okay. So let's start. And guys, if you got any question, any doubts, you can ask me in the comments. Okay, let's continue. So, router 1 can connect to three other networks, router 2.0, 3.0, 4.0. Okay, let's write them down. 192.168.2.0 से connect हो सकता है. It can connect to 192.168.3.0. It can connect with 192.168.4.0, right? It can connect with these. This is a very important thing where many students get stuck in this topic. Okay, so be careful and just watch it carefully, very carefully. So if it wants to go from like the packet travels from this, okay, to it goes to this router. What will be the next hop? Next hop will be the first hop here. Okay, here it's gonna go over here. B. If it wants to go to 2.0, it wants to go to 3.0, it wants to go to 4.0, it will just hop to the B. Okay, so here packet comes, it wants to go to 2.0, the next hop will be B. Next hop is always your first hop. The packet come from A to B. Okay, so first hop B. Okay, if it wants to go to 3.0, it will go next hop, your first hop 1, 2, 3. There are three hops if it wants to go to this one. But if it wants to go to this one, it needs to go to 3.0. The next hop or the first hop will be this B again. Okay, so every time it will be B if the packet is moving from 1.0 to any other network to the right, the first hop or the next hop will be B. Okay, so router 1 wants to connect to router 192.168.2.0 or 192.168.3.0 or 192.168.4.0. It will hop to B. Okay, so I'll show you it in the practical as well. Don't worry about that. And thank you, sir. Best networking teacher I know. Thank you so much, sir. Okay, next we have got 2.0 network over here. Okay, so there is another this router. We have got second router. Now it can connect to three more networks. This is the network 1, 1.0. This is the network 2, 3.0, and this is the network 4 it can connect to. Right? There are three networks again. So let's write those down. I have got 192.168.1.0 to which router 2 can connect to. Then we have got 192.168.3.0 it can connect to. Then at the last, this router has got 192.168.4.0 it can connect with. Okay, so these are the devices, these are the networks router 2 can connect with. Okay, so if it wants to, this router wants to send packet from this network to here, what will be the first hop or the next hop? This one, class A. Sorry, class A. I'm so sorry. A. A will be the first hop. Here I'm gonna put A. Where is it? Here. If router 2 wants to send the packet to this 1.0 network, it will send the packet to A. Okay. If it wants to send the packet to this network 3.0 network, where it will forward the packet? Here. One first hop. Here. It will send it from C to D. Okay. So here the next hop will be D. If it wants to send the packet to 4.0, so one hop, two hop, three hop. But what's gonna be the first or the next hop? D. Okay, so it's again gonna be D. I hope guys you're getting it. If you are not getting it well, you can ask me in the chat. I can explain it to you again. Okay, next we have got router 3. Now this router 3 this network wants to send packet to 2.0 network, 1.0 network and 4.0 network. Let's write down these networks again. We have got 192.168.1.0 network. We have got 192.168.2.0 network. We have got 192.168.4.0 network. We have got all these networks. Okay. Now it wants to send the packet. Okay. Now let me just. Okay. So this router, where is the three router? Here. This is the third router. Now the packet is coming from this network. It wants to send the packet to this 1.0 network. So what will be the hop? The packet from D will travel to C, then B, then A. What is going to be the first in the next hop? It's going to be the C. Okay. It will be C. It will go to C. It will forward the packet to C. So it's going to be C over here. If it wants to send the packet to 2.0, okay, it wants to send the packet to 2.0, where it will send again to the C. From D, it will send it to C. So what's going to be the first or the next hop? Pehla hop, agla hop, it's gonna be C again. You're gonna put C over here. And last we have got 4.0 network. Now it wants to send the packets to its right, and where from E to F. So the packets coming from here, it lands on it's this port. It's gonna send it to the F port. Okay, so here I'm gonna put the F. So this is how the routing table is made. Okay. Where is it? Just a second. Uh, Give me a second. Let me search for it. Okay, here. Now, last router we have is 4.0. So it has to all the networks are present on its left, right? On its left, the first and the next hop is which one? E, right? So it's gonna send no matter which network it has to send the packet to. Like it has got network 1.192.168.1.0. It has got network 192.168 dot 2.0. It has got the last network as 192.168.3.0. Which port it will rely on to send the packet to? It will simply send it from F to E. This is going to be the first or the next hop, not the last. Okay, so there are multiple hops. If it wants to send the data from 4.0 to 1.0, there will be many ports: F to E, then E to D, then D to C, then C to B, then B to A. But what's going to be the first and the next hop? That's going to be your E. Okay, and if wants to send the packet to 2.0, there are going to be many ports like F to E, E to D, then D to C. But what's going to be the first and the next hop? That's going to be your E. And if it wants to send the packet to this 3.0 network, what's going to be the next or the first hop? Here, E. So this is how the routers maintain their routing table. So let's review it one more time. Okay, if you got any doubts, any questions, guys, you can ask me. Then we will see it in the Cisco Packet Tracer network. So router 1 here, it wants to send packets from 1.0 to 2.0, 3.0, 4.0. It wants to send the packet to the right. So from A, it will send the packet to the B every time. Okay, because it do not have any other port connected to it. So it will directly send it to the B. Now we have got the router 2. We've got the router 2. On the left, it wants to connect to 1.0 network. It will send whosoever it wants to connect on to the left. The next hop will be A. And if it wants to connect some network, on the right, it will send to the D. So here you can see on the left, it will send the packet to the next hop as A, and it will send to the packet on the right as the next hop on D. Then third one has got on the left, it has got C, and on the right, it has got F to forward the packets. So here you can see on the left, we have got 1.0 network, 2.0 network. The next hop gonna be C, and the 4.0 has got on the right the packet. Here you can see the port as F, so it will send it to the F. So, and last one is your fourth one, and it has got 1.0, 2.0, 3.0. So it will ultimately send all the packets through the E port. The first and the next hop is going to be E, and then later it will be forwarded to other ones. So that's it. That's all we needed to learn for the static routing. Now let's see in this network. So I go to this network. So which network? This is 1.0 network, right? And I want to connect it with the 2.0 network. There is no other network. Okay, we will see with the three routers as well. Okay, so what will happen? I will simply put here 2.0 and the subnet mask of that network. And what's going to be the next hop? Next hop, it's going to be, this is the router's first one. So it's going to send the IP, the packet from here to here, 10.0.0.1 to 10.0.0.2. So this 10.0.0.2 is going to be the next hop. So let's just add it. IP root. I went to the static. Okay, add. I just took a while to like just type the command. That's why it was showing some error, but it will not show the error when you do it. Okay, so this is simply I needed to do for sending it to this one. I need to uh, do this one 10.0.0.0. Okay, I've got the subnet mask and I've got the network. That's it. Okay, I've got just one router over here. And now you know if no matter how many routers are connected on the left or right, you will know how many, which next hop you have to give, right? If you have got that image thing really clear. If you haven't got it yet, you can ask the doubts in the chat, or you can ask the doubt on the number that is given in the description. Okay, now let's type over here network. You have got again here you have got 10.0.0.1. Sorry, I'm so sorry. The next network, this one has the network 192.168.2.0, and this one has got 192.168.1.0 network. So it needs to connect, this router needs to connect its private network to the other private network. So here I'm going to put 192.168.1.0 over here. Okay, and the subnet mask will be 255.255.255.0, and the next hop is gonna be this one 10.0.0.1. Okay, because it will send from this to this. It will send the packet from on the left, it is forwarding the packet to 10.0.0.1. I hope this thing is clear to you guys. If it is not clear, you can ask me in the chat and I can explain it to you again. There is no issue. Okay, because in the static routing many people get stuck. Now I'm going to give you a small homework. Okay, I have done it using the two routers. Okay, I've done it using two routers. You need to do it using three routers. Okay, let me help you with that. Let me help you how you are going to start with it. So let me copy this small network first of all. Control C, Control V. Okay, let me help you. So here you're gonna add one more. You will need one more router. Always take this router, okay? You need to take this router first of all. Why? Because this has got three ports. Okay, this has got 2 gigabit Ethernet ports. So you do not need to add any ports. I will tell you how to add the ports in this as well. I have already told that, but I will tell you again. Okay, in the upcoming video lectures. And then you connect it using the crossover cable. Here it has got the last port because it has got only one left port. If you do not take the same router or the other router that has got three ports, you will not be able to do it. So select this 2991 router, then connect these. Then you also take a PC. Okay, make whole network on your own. Okay, I'm just showing you what you need to do. Okay, and I'm gonna give you some PCs. Then Control Shift and select the PCs and connect them using which cable? Straight through cable. Okay, this is your homework, guys. I'm just helping you with it a little bit so that most of you can do it easily. And if you got any doubts, you can contact me on the number that is in the description below. The demo class we have is free of cost as well. Okay, you can contact on the number in the description for the free demo class as well. Okay, so here you can see this one had we already know that this network was 192.168.1.0. This had this IP, these IPs, these had these IPs. So I'm going to help you with the IP giving, to give IPs over here to the new students. Okay, here I'm going to put the 11.0.0.1 network. Here I'm gonna give the complete different network. Okay, for the clarification, you also use this one only. Okay, here you need to give the IP address of 192.168.3.0 network. Okay, here I'm going to give the IP to this port as 192.168.3.1. Here. Okay, and here you need to give the IP addresses to this system as 192.168.3.1. Here you need to give the IP addresses as 192.168.3.2. Okay, I hope I'm making it clear to you guys. And this is what IP addresses you're going to use. So for this port, you're going to give IP this one. For this port, you're going to give this IP. For this port, you're going to give this IP, and that's how it's gonna work. Okay, make sure to remember, do not miss out this port numbers. Okay, just the port numbers that are shown in my Cisco Packet Tracer might not be same as shown in yours. Okay, they might be, there might be gigabit Ethernet 0/0 over there and 0/1 over here. So you need to see that thing. You need to write the IP addresses correctly on each port. Okay, so I hope this is clear to you. You need to configure this one as well. And let me show you guys, I forgot to show you. Here, if I send the packet from one system to another one, the first packet will fail, but the second packet will work well. Just a second. Let's do it in the above one. The first packet should fail and the second packet will work. Should work out. Okay, here you can see it's successful. Okay. Why first packet will fail? Can anyone tell me? Okay, again sending the second packet, it's successful. Okay, why first packet will fail, guys? Do you have any idea about it? And guys, do like the video and subscribe to the channel and keep asking your doubts with us. Okay. Okay, why first packet is failing, guys? And no one even answered to my question when I asked you what's the difference between port and the interface. Guys, we have discussed it several times. How can you just miss out on that? Okay, and I'm gonna be live on Monday from 3 to 5 regularly from now on. Okay, tell me everyone, what why the first packet was failed? Because it need to update the routing table, it need to update the MAC table. So it has got some own reasons of the ARC. Okay, I told you about address resolution protocol. So that protocol is in your role. So that's why it takes a little bit of time. Okay, so here, if I send the packet from here to here, I just copied the network, right? So now you will see it's also sending. So it takes some time for the first time to send the packet if you have configured it well. But if more than one packet is failing, there might be some problem with the network. Either you haven't given the default gateway or you haven't configured the IP address really well. And you got any questions, you got any doubts, you can ask me in the chat, or you can ask me on the number that is given in the description. I'll be really happy to help you guys with your doubts and everything. And I gave you the homework already. So I've already explained how you can connect it to the even four routers. Okay. So you need to now know, like figure it out on your own, what routing table you need to give, what IP addresses you need to give. I've already mentioned everything on the top, right? I've already given you the full thing in play. Like in the plate, you already know what things are there, right? You just need to configure one more router. That's it. Okay, that is your homework. You need to do it with the three routers. I've already shown you it with the two routers. Okay, now we will do the further in the on the Monday. Okay, and if you got any doubts, got any questions in any topic, and it's related to networking or ethical hacking, you can just ping me and I will just answer to all your questions. Thank you so much, everyone, for your support. Do not forget to like, share, and subscribe. And I will see you on Monday, 3 to 6 and 3 to 5. Sorry. And I will be regular. Okay. Tomorrow I've got classes on 3 to 5. Otherwise, I have got 3 to 6. I have class tomorrow. Otherwise, I would have taken the live class again. I've got no issues with that. Thank you, everyone. See you. And I'll be really happy if you talk to me in the chat more. Okay. We have got 11 watching. We have got only 10 likes. So I would appreciate even one more like. Right. Bye. See you on the Monday, 3 to 5. Definitely.